Okay, we have chapter 9, section 5. We're actually going to do parts 1 and 2 in the same video because they're similar and short. All right, adding and subtracting rational expressions. Here comes the part where you must know how to factor. You have to know how to factor. You have to know how to build a common denominator. These problems are not difficult, but they are sometimes they can become a little bit long. Now, on this first note sheet, they're not that long. The second one, a little bit longer. Let's see what you could do with these problems. Okay, so organization is going to be key. And those of you that do puzzling on your homework, please don't do that for these, unless you're going to make straight separators like this, okay? Because it's going to be too difficult for me to find your work. All right, adding and subtracting rational expressions. What do you do if they already have the same denominator? Well, you add or subtract the numerators, and then you place the result over that common denominator, which is our LCD. Simplify if possible, and then list the domain restrictions. List domain restrictions. Now, listing the domain restrictions is different than giving the domain, all right? The restrictions is what X is not allowed to be, and the domain is what X can be, all right? So don't mix those two up. So we'll do list domain restrictions / give the domain. They're similar, but they're different. All right, let's look at the first example. We have x over 8 plus x over 8. Notice the denominators are the same already. Folks, this becomes x plus x over 8. And 1x plus another 1x is 2x over 8. Notice the 2 and the 8 have a common factor. I can simplify this because this is multiplication in between the 2 and the x. So 2 divides 2 one time, 2 divides 8 4 times. So my simplified answer here is x over 4. Now, notice there are no variables in the denominator, so there are no restrictions. No restrictions, so the domain is negative to positive infinity. Okay, that's part of the answer. All right, let's take a look at example 2. Notice the denominators are the same already. So what do we have? Now we have quantities. Folks, these are quantities, and you must group, especially the second one, because you have a subtraction sign there. All right, so I have 7 plus x, subtract the quantity 3 plus x over the one common denominator, 2x. Simplifying, 7 plus x, subtract 3, subtract x, all over 2x. Well, 7 subtract 3 is 4. X subtract x is no more x. So this becomes 4 over 2x. Notice the 2 can divide the 4. They have a common factor of 2. This becomes a 1. This becomes a 2. So my final simplified answer here is 2 over x. X is not allowed to equal 0. That's the restriction. The domain in interval notation is negative infinity to 0 in union with 0 to infinity. Okay, so just know that we need the restrictions to build the domain. Okay, the restriction is what x is not allowed to be. The domain is everything that x is allowed to be. Okay, so they're related, but it's not the same thing. If you have questions, please ask. All right, let's take a look at example 3. Notice the denominators are the same already, so I just put that over 3. Top is 2x subtract the quantity, x minus 1. This becomes 2x subtract x, add 1 over 3. Simplify, 2x subtract x is x plus 1 over 3. No common factors, right? This is a quantity. That's an integer. Final simplified answer. No restrictions. I don't have an x or any variable in the denominator, so there are no restrictions. So my domain is negative to positive infinity. Example 4. Denominator is the same already. It's a quantity, a minus b. What do I have up top? 5a subtract. Since this isn't a quantity, I don't technically need parentheses. Notice in the numerator, my binomial has a common factor. It has a 5 in common. So I'm going to factor out the 5. This becomes a minus b over a minus b. I have a common factor. The a minus b's will divide out. So my final simplified answer here is 5. Now this one's going to be a little bit difficult for us to give the domain, but we are going to give the restrictions. A, set it up if you don't know how to find the restrictions in your head. A minus b cannot be 0. So A cannot be b. Do it again. A minus b cannot equal 0. This time solve it for b. Negative b cannot equal negative a, so b cannot equal a. If you get an a can't be b, then it's obvious that b can't be a. A can't be b, and b can't be a. So those are my restrictions. Again, it's a little bit difficult to write the domain with restrictions as such, so we just let that go. But if we have actual integers, then we, because this, we're not talking about actual specific real numbers that the variable can't be. We just know that a and b can't be equal to each other. All right, example 5. Why don't you try example 5? Pause the video and try example 5. Okay, hopefully you paused the video and did this problem on your own. Notice the denominators are the same already, so I put the two numerators into one numerator, being careful to use parentheses because I am subtracting this quantity, which means I have to distribute the negative. Notice when I combine like terms, positive 5 and negative 5 are opposites. They're going to sum to 0. 2b minus 4b is negative 2b over 3b, and the b's are going to divide out because it's multiplication in the top and the bottom. Final answer is negative 2/3. So no matter what value that I choose for b that I substitute in here, I'm always going to get a negative 2/3. Always. Except when it's 0. Okay, now here we have a definite value, an integer. And so we can give the domain when we know those specific values. All right, example 6. Let's see if we can buzz through this one fairly quickly. Now, notice I have an addition sign. So I don't really need to group this because I don't have, if I distributed positive to all of those, all these signs are going to stay the same. It's when it's subtraction that you have to group it. All right, so be cognizant of that. This is 3a, subtract 3b, add 5a, add 5b, add 1, all over 20. All right, my a's, 3a and 5a is 8a. Negative 3b plus 5b is plus 2b plus 1. all over 20. Now, try as you may to factor this. Even if it does factor, you're not going to get a 20. So it seems, how would you say, pointless to try to factor this, because the purpose of factoring would be to simplify further. And the GCF up here is not 20. It's 1. All right, so this is my final answer, simplified, after I added the two fractions. Notice there's no variable in the denominator, so there's no restrictions. Hence, no restrictions, my domain is negative to positive infinity. Okay, so if you have questions on that, let me know. We're going to bounce over to the second part of 9.5, adding and subtracting rational expressions with different denominators. Now, these require a little bit more work because you have to get a common denominator. You must make the denominators the same by finding the LCD, the least common denominator. Which is the product of the distinct factors. All right, let's look at example 1, because this one's pretty straightforward. LCD is the product, which means multiplication, of the distinct factors. 3 is prime, 7 is prime. They are different. 3 times 7 is 21. 21 is my LCD. I'm going to copy this problem, y plus 7 over 3. Subtract. These are quantities. Let's do y minus 5 over 7. Okay, that's the original problem. Now, folks, I need to make this be a 21 and this be a 21. So this becomes a 21 by multiplying by 7 over 7, and this becomes a 21 by multiplying by 3 over 3. The top, this fraction becomes 7 times the quantity y plus 7 over 21. Now, these are both going to be a 21, so I'm just going to write in one single fraction bar over 21. The sign is negative, so it's subtract, and now I've got 3 times quantity y minus 5 over 21. Now I have to distribute because you have to simplify this. All right, so we'll say equals, equals. All right, in the top, 7y plus 49. Subtract 3y, add 15, all over 21. 7y subtract 3y is 4y. 49 plus 15 is 64, all over 21. 4 and 64 have a common factor. If you don't know that the common factor is not going to simplify the denominator, then just factor it out anyway. 4 times quantity y plus 16 over 21. So 4 and 21 have no common factors. But if they would, you would have to simplify that. All right, so this is my final answer. There are no restrictions because there are no variables in the denominator. So my domain here would be negative to positive infinity. Okay. Example 2. First denominator is 9. Second denominator is 36. Well, when you're building your LCD, you need everything in the first denominator. That's a 9. 36 is really 9 times 4. Folks, the 9's already in there. The 4 is not, so I have to put it in there, and my least common denominator then here is 36. All right, so now I'm going to copy the original problem. I'm going to multiply fraction 1. I have to multiply by 4 over 4 because I have to get this 9 to be a 36. This is already a 36, so that's just simply by 1 over 1. You don't have to write it, but if you like that structure, then write it. All right, what do we have here when we multiply this? Well, that's 4x over 36, and this is 5x over 36, or 4x plus 5x all over 36. 4x and 5x is 9x over 36. Now notice 9 and 36 have a common factor, 9. Okay, that becomes a 1. This becomes a 4. So my final simplified answer is x over 4. No restrictions. Domain, negative to positive infinity. Okay, one more example. LCD. Well, the first denominator has 3 m's. You need everything in the first denominator. Okay, it's 3 m's. M times M times M. This has 2. Well, guess what? These 2 m's are those 2 m's, and this extra m is in there already. So my LCD is m to the power of 3. Okay, I don't add those. 3, 4, 5, 6. That's not the least common denominator. It could be a common denominator, but it's not the least common denominator. If you put too much in, then you have to simplify and do more work at the end. All right, so my LCD, my common denominator is m cubed. So I'm going to write my 3 fractions. And I'm going to put some space here because I'm going to multiply this fraction and the third fraction by something to make all the denominators be the same. Okay, if you noticed up here, I just put what I had to multiply by on the left side of this fraction and the right side of that one. But when I have 3 fractions, I need to leave some space. All right, LCD is m cubed. That has an m cubed, so that's just simply multiplied by 1 over 1. This is an m squared. I got to make it be an m cubed, so I need an m over m. This is just an m, so I need an m squared over m squared, right, to make that be an m cubed. Now, all 3 of them are over m cubed. 1 times 6 is 6. 3 times m is plus 3m. Negative 2 times m squared is subtract 2m squared. The only thing left to do is decide, does this have any common factors to divide out here? Well, no, they don't all have an m. That's the only thing I would be able to divide out anyway, because there's only m's in the bottom. But we should rearrange this in order of descending powers. Negative 2m squared plus 3m plus 6 all over m cubed. Now notice m cannot equal 0. It's in the denominator. And so my domain is negative infinity to 0 in union with 0 to infinity. So, if you have any questions, please ask so that I may help you. Have a great day.